When you look up at the sky on a clear day, the sun feels like the most familiar thing in the world. We depend on it. We feel its warmth. We see its light. But here's the shocking truth most people don't realize. The sun is far stranger, far more dangerous, and far more unpredictable than it looks from Earth. It's not just a glowing ball of fire calmly burning in the sky. It's a raging, unstable engine of plasma that hides violent storms, deadly eruptions, and mysteries that even today's scientists are still struggling to explain. And what we think we're seeing when we look at it isn't even real. When you step outside and look at the sun, you're actually staring into the past. The light that hits your eyes is already more than 8 minutes old. That means if the sun suddenly vanished this second, Earth wouldn't even notice until over 8 minutes later. But that's only scratching the surface. The light you see doesn't come straight from the sun's core. Photons are born deep inside, under crushing heat and pressure. But before they escape into space, they spend thousands of years colliding, bouncing, and zigzagging through the sun's dense layers. By the time a single particle of light finally breaks free and races toward Earth, it could be anywhere from 10,000 to 170,000 years old. Think about that for a moment. When you look at the sun, you're not just looking 8 minutes into the past. You're also seeing energy that was created before human civilization even existed. Some of the sunlight falling on your skin right now may have been trapped inside the sun's core, back when mammoths roamed the Earth. And if that doesn't already blow your mind, wait until you hear what's happening in the layers we can't see. Let's start with the corona, the sun's outer atmosphere. At first glance, it doesn't even make sense. The surface of the sun, known as the photosphere, burns at around 6,000 degrees Celsius. That's unimaginably hot. But strangely enough, the corona above it reaches more than 1,000,000 degrees, hundreds of times hotter than the surface itself. This bizarre temperature jump has left scientists baffled for decades. How can the atmosphere be hotter than the fire below it? It's like walking away from a bonfire and feeling more heat the further you get. We usually can't see the corona at all because the photosphere is so blindingly bright. But during rare total eclipses, when the moon blocks the sun's disk, a ghostly crown of light suddenly appears in the sky. That glowing halo is the corona, a shimmering outer layer stretching millions of kilometers into space. Still, even an eclipse can't reveal its full details. That's where NASA's Solar Dynamics Observatory comes in. By using extreme ultraviolet light, wavelengths invisible to the human eye, scientists can see stunning details of the corona, arcs, loops, and magnetic structures twisting across the sun. But the corona isn't just beautiful, it's also violent. And some of the things lurking there can change life on Earth in ways most people don't expect. Every now and then, the sun snaps. Magnetic fields deep within its plasma twist and collide until they suddenly release their stored energy in a colossal explosion called a solar flare. Imagine a blast so powerful it could dwarf the size of Earth. A solar flare can hurl out more energy in a few minutes than all the power plants on our planet could produce in hundreds of years. They're mesmerizing to watch. Fiery flashes rippling across the sun's surface, lighting up space with bursts of radiation. But they're also terrifying. These flares release intense streams of electromagnetic energy that can mess with Earth's satellites, radio systems, and even power grids. Back in 1989, a solar storm knocked out power to 6 million people in Canada for 9 hours. And that wasn't even the strongest the sun is capable of. Scientists worry about what would happen if a truly massive flare, the kind that hits once in a century, were aimed directly at us. And yet, solar flares are just one of the sun's weapons. There's something else lurking in its atmosphere that's quieter, but just as dangerous. Look at images of the sun in ultraviolet light, and you'll notice dark patches. These aren't shadows, They're called coronal holes. In these regions, the sun's magnetic field opens outward instead of looping back. That open pathway allows streams of charged particles, solar wind, to pour out into space at incredible speeds. When these winds happen to collide with Earth's magnetic shield, they can set off dazzling auroras. Those green and purple lights you see dancing over the polar skies? That's our planet's defense system, lighting up as it battles the solar wind. But here's the double edge. While auroras are beautiful, the same solar winds can also overload satellites, disrupt GPS, and even threaten astronauts in orbit. The same holes that create wonders in the sky can also trigger chaos in our technology. And if you think that sounds dangerous, you haven't seen what happens when the sun doesn't just leak wind, but launches a cannon blast straight at Earth. Sometimes the sun builds up so much tension in its magnetic fields that they snap like a slingshot, unleashing billions of tons of plasma into space. These are coronal mass ejections, or CMES. Picture a storm cloud the size of multiple Earths being hurled across space at millions of miles per hour. If one of these eruptions collides with Earth, the results can be catastrophic. Satellites could be fried. GPS and communication systems could collapse. Electrical grids could short out, plunging entire regions into darkness. The last time we narrowly escaped such a disaster was in 2012, when a massive CME missed Earth by just a week. If it had hit, experts believe the damage to global infrastructure could have been in the trillions of dollars, and recovery might have taken years. The sun isn't just a glowing star. It's a loaded cannon pointed at the solar system. And while some of its blasts escape into space, others fall right back down, in ways you probably wouldn't believe. Not every eruption escapes the sun. Sometimes, instead of blasting into the void, plasma gets caught by magnetic fields and loops back toward the surface. These arcs are called prominences, and they are some of the most breathtaking structures in the solar system. Picture a glowing ribbon of fire, stretching hundreds of thousands of kilometers into space. Some of these loops are so enormous, Earth would look like a pebble beside them. And here's the wild part. They can form in just a day, but some remain stable for months, locked in place by invisible magnetic ropes. When sped-up time-lapse images show them writhing and twisting, it almost looks alive, as if the sun itself is breathing, exhaling rivers of flame that bend and curl before collapsing back into its atmosphere. But not everything that rises up in the sun's atmosphere stays suspended. Sometimes the sky above the sun literally begins to rain. It sounds like science fiction, but it's real. The sun has weather. And yes, sometimes it rains. Here's how it happens. Plasma ejected into the corona doesn't always escape into space. Some of it cools down just enough to condense into denser blobs. Trapped by gravity, these blobs fall back to the sun's surface, creating glowing streaks that look eerily like rainfall. From Earth, you'd never see it with the naked eye. But through solar telescopes, it's a surreal sight. Golden rain cascading down at speeds of hundreds of kilometers per second. Unlike Earth's rain, though, this isn't refreshing water. Each droplet is a chunk of superheated plasma, millions of degrees in temperature. Coronal rain is both beautiful and terrifying. It's as if the sun itself has thunderstorms. Except instead of water and lightning, it's molten plasma pouring from the sky. And yet, even coronal rain pales in comparison to one of the sun's most violent displays of power, the ejection of entire structures into space. What makes the sun even stranger is that it never looks the same twice. Not depending on time, but depending on the light you use to look at it. Take two images of the corona captured at the same time, but in different wavelengths. In one, the sun looks relatively calm, with quiet loops of plasma arching gracefully across its surface. In another, imaged at higher energy, the sun transforms into a battlefield, with furious storms and blinding hot regions bursting with activity. It's like peeling back layers of reality. What seems serene at one wavelength reveals chaos at another. The sun doesn't have a single face. It has many, and each one tells a different story. This is why scientists rely on instruments that scan across the spectrum, from ultraviolet to X-rays, to truly understand the beast we live beside. Because when you see the sun in just one way, you're only getting a fraction of the truth. And those shifting faces of the sun follow a rhythm, one that decides when Earth will be at greater risk. The sun isn't always equally active. It pulses through an 11-year cycle, swinging between quieter periods and times of extreme turbulence. During the quiet years, flares and storms are rare, but as the sun ramps up to its peak, called solar maximum, eruptions become frequent and violent. Right now, scientists say we're heading into a solar maximum. That means more auroras lighting up the skies, but also a higher chance of storms, powerful enough to knock out satellites and electrical grids. The cycle has been ongoing for billions of years, and Earth has lived through countless peaks and valleys. But with our modern world so dependent on fragile technology, the next big solar storm might not just be a spectacular light show, it could be a global crisis. And that's the chilling paradox of the sun. The same star that gives us life also holds the power to throw us back into the dark ages in a matter of hours. When we look up, it's easy to think of the sun as constant, reliable, eternal. It rises every morning, sets every evening, and keeps our planet alive. But beyond its golden glow lies a violent, unpredictable monster. It rains fire. It hurls storms larger than Earth. It unleashes flares that could silence satellites and winds that paint the skies with light. It can be breathtaking, awe-inspiring, and devastating, all at once. We depend on it for survival, yet it could be the very force that tests the limits of our civilization. And that's what makes it so fascinating. The sun is both our greatest ally and our most unpredictable threat. So the next time you feel its warmth on your face, remember, you're not just basking in simple sunlight. You're touching ancient energy that was born before human history even began, shaped by forces we're only just starting to understand. And somewhere deep inside that fiery heart, the next great storm is already forming. The only question is, when it finally erupts, will we be ready?